Hello and welcome to the TrapTagger tutorial. My name is Nicholas Osner and I'm the project lead on TrapTagger. So the idea with this tutorial is to have a set of videos that walks you through the system and how to use it, and then to have some separate sort of advanced use case videos that you can watch thereafter. So basically we're starting with this introductory presentation where we talk about how the system works and why it works that way, so that you have a good base understanding of what you're dealing with before you actually start trying to annotate data with the system. So we'll then move on to demonstration, and it's strongly recommended that you watch these videos in order from beginning to end and then revisit topics as needs be thereafter. So the basic idea is that obviously camera traps generate a lot of data. So we want to be able to annotate all this data automatically using artificial intelligence. So we actually use separate AIs for each step in that process. So firstly, we need to detect the presence of animals. So for that, we actually use Microsoft's Mega Detector, which is an open source project that does that. And basically the idea is that it generates these boxes around the animals, called bounding boxes. So that then helps us detect the presence of animals and by implication, the absence of animals. And then we can also count those boxes to generate counts of the animals in each of the images. What's great about Mega Detector is that it's been trained on an international data set and in a variety of environments, so it should work quite reliably across any biome. The second AI in this process is the species identification, the species classifier. So the idea is that we have a number of internal classifiers for different regions, and they then look at those images and determine what species they are. And then lastly, we have another AI that tries to assist with identification of individuals. At present, we actually use Hotspotter, which is an open source industry standard pattern recognition algorithm. So it's a code pattern recognition algorithm that we use there. And we'll go into detail on some of those later. But the main point there is that, like humans, the AI makes mistakes as well. But what it does do is that it generates a confidence score. So it'll look at that image and say, it believes that that is a leopard with 95% confidence. So then we can say anything above a certain confidence threshold, we can accept that it's probably correct. But anything below that, the AI is insufficiently confident of the species they're in and should rather have a human look at it to make sure it's correct. So basically, with that in mind, from the start, we built the website to be as sort of annotationally efficient as possible, so that you're able to then use this efficient interface to always annotate those images where the AI is uncertain of the species. So basically, we'll see a lot of sort of the features there and how we do that, make it annotationally efficient in the actual demonstration. But basically the idea is first and foremost that you're able to use a number of workers working in parallel, which obviously makes things a lot faster. But we also do a number of things. We try and reduce data usage so everything's just fast and snappy and easy to use. We have various image tools that can change the brightness and contrast in challenging lighting situations, stuff like that. If a camera's been knocked down and spamming images, you can mark it as such and sort of put those images aside for later. And things like that, and also the hierarchical label structure, you're able to only focus on your species of interest. But sort of the combination of all of that is that through the site, you can look at 2,000 images per person per hour in parallel. So, and that's before you even take into account the removal of empty images or species classifications or image clustering, which I'll discuss shortly. The point is, you're actually effectively processing a far higher number per person per hour than that. But so as you can see, with a whole lot of people, with a number of people working in parallel, you can get through a lot of data very quickly. The secondary advantage of this approach, this annotationally efficient approach, is it means that you can actually use the system in biomes or environments where there is no species classifier. So Mega Detector, as I said, is trained on an international data set, so we can still reliably remove the empty images for you, and then you can actually then manually annotate all the animal-containing images in terms of the species they contain. And then once you've got sufficient training data, we can actually then we can train a classifier for you. And that's actually how Wildcrew processed their initial set of training data when we were developing the system. So they processed in excess of 1 million images over a couple of months while their master student was doing other work in the background. So it's very usable in that way. So I'd mentioned briefly about image clustering. So basically the idea there is that an image cluster is essentially a unit of data, quite literally a cluster of images. And basically the idea is that the site or the platform is set up to work with one camera per site or multiple cameras per site. And in particular, we always look at our reference case is Wildcrew. And what they do is they have 2 cameras on either side of a game trail so that they can get both sides of an individual as it walks through for individual identification purposes. So the idea is if you have like a herd of antelope that walks between those 2 cameras, each camera triggers, say, 10 times. And I've got 20 images, and you only have to look at one to be able to say, okay, that's impala or antelope or whatever you want to label it as, and move on. So that's sort of the basic idea. So you can get, massively improve your annotation efficiency in that way. But it's also got other advantages in that it improves our AI performance. That with the species classifier, you only that you're looking across multiple images to determine what species it is, or you just in terms of detection, you only really have to detect at least one animal in the whole set in order for that cluster to actually to capture those animals. So it also improves performance there. But it's also good just in terms of results. It just gives you another unit of data that you can export your data in. So your results in. So that you've got the triggers recorded rather than the images, which can get affected by a herd spending a lot of time in front of a camera. It creates a hotspot and creates a lot of images when it's only one sighting of animals. So basically what arises from all of this, that we've got this efficient annotation interface, is that you can use the site in a number of different ways that sort of allows you to have a speed accuracy trade-off. So basically, like with anything in life, you can either do it quickly or you can do it accurately. And the idea is basically trying to find, obviously, sort of the best compromise between those 2 extremes. So the one way you can use the site, so the one end of the spectrum, is to go for much higher accuracy, and that's to manually annotate the data. So we still remove the empty images, but you manually annotate the species in all of the animal-containing images and use the AI as an aid to make that process quicker and easier and more accurate. And once you've done, you've got a set of annotations. You can then check the AI's set of annotations against yours to find mistakes, because there's always inevitably some element of human error. And then correct those mistakes and sort of get the most accurate set of data as possible. So that approach is very popular with, say, academic institutions, where obviously you want very high accuracy and you have a lot of manpower available to you. But then on the opposite end of the spectrum, you can go for a much more automated approach, where you have all the species automatically identified for you as far as possible, leaving the images where the AI is uncertain of their contents for you to manually annotate. And that's typically around 5% of the data set. So it's far less annotation if you do, it's far quicker, but it's slightly less accurate. So it's sort of, it's more, it lends itself more to applications where accuracy is less important and speed is more important. So that's, sort of more fieldwork type applications, an ecologist just needing results quickly. But the whole point is this is on a spectrum that you can actually choose for a compromise between those 2 extremes, where you're actually able to select on a per species basis which species are automatically identified for you. So again, looking at Wildcrew's use case, they are looking at large African carnivores. So that's lion, leopard, cheetah, wild dog, and hyena. Anything else is really superfluous to that. So basically the idea is then you can choose very different looking species that aren't going to be confused with your species of interest, to have those automatically identified for you. So in this case, you can have, say, elephant, giraffe, and zebra automatically identified for you with, very little chance of there being, confusion between those species. So you can still get very good accuracy on your species of interest, whilst drastically reducing the number of images you need to annotate and manually look at. So that's sort of the basic idea there. So to really compare how these different approaches perform and to benchmark the platform's performance in general, we looked at a we performed a benchmarking exercise on a data set of 43,000 images from the Okavango Delta, some wild cruise data, and basically this was data that their service manager had previously manually annotated prior to their involvement with us, and so we used that as our benchmark. So obviously you'll see that it's not 100% accurate. We did go and try and correct it and find mistakes as far as possible so that we had a golden data set to compare everything to. So basically we've got that reference data set is the traditional row. Then we've got the AI aided approach, that's the more manual approach. We use the AI as an aid, is the second row. And then the third row there is the AI annotated approach. That's the much more automated approach. And we're comparing these in terms of precision and recall. And basically, so just to recap that for you, so basically precision is if we label something as an elephant, what percentage of the time is it actually an elephant? Whereas recall is, of all the elephants, how many did we find? And basically the idea there is that you need to perform well on both of those metrics, where basically the idea is that you could mark everything, the entire data set is containing elephant, and have 100% recall, but virtually 0% precision, or do the opposite, where you just label one elephant as elephant and walk away and have 100% precision, but 0 recall. So you're trying to perform well on both those metrics. So so basically on our traditional data set there, we've got the point is the service manager hadn't actually recorded the time they spent on the survey, but he said it took him about 2 months, which is where the 320 hours comes from as an estimate. Then we've got the AI-aided approach, and you'll see that its precision and recall are virtually on a par. There's no statistical significance between those two values. And essentially the point being, though, that only took 5 hours for the student to annotate. So she only had to look at about 9,000 images in this case. So it's orders of magnitude faster, but for essentially the same performance. And then in comparison, the more automated approach, we've got then essentially on a par precision, but a full percentage point lower recall, but it is 5 times faster. The student only had to annotate 2,000 images. So that's sort of the trade-off you have to make, and it comes down to your particular use case as to whether that trade-off is worthwhile, and to go from there. But to sort of delve a bit deep into that, we can look at the error modes of those two the two data sets, the data annotated through the site and the reference data set. So in this case, he has a random selection of errors from the reference data set, and basically the idea there is that you'll see that they're all easily identifiable images. They were just simply human error. There's always some element of human error, and they were just filed incorrectly. So the errors are relatively uncorrelated and just of often good quality images. Whereas the data annotated through the site, the errors tend to occur where the AI has failed, and where the AI has failed is not not completely uncorrelated. It's actually tends to be where the image quality is poor and where it's struggled to identify the presence of an animal, for instance. So here's again random selection of 6 errors, and actually in all these cases the AI has just plain failed to detect the presence of an animal. And what I have had to do on all these images, I've manually for this presentation gone through and increased the brightness, dropped the contrast and stuff like that, manually processed it to make the animals as visible as possible. I think you'll agree with me, they're still quite challenging to see despite that. So basically we've got an elephant over there, a hyena over there, buffalo there, a porcupine over there, a buffalo over there, and an elephant over there. So basically the point really being that as much as on paper the precision recall of the AI aided approach it's on paper the same as the reference data set, the performance. The mistakes that you tend to be on low quality images. The images that you lose are of lower quality and hence of lower value. So then to continue, I spoke earlier about sort of how we use AI as an aid to this annotation process. And so basically the way we do that is we essentially, again, I've spoken about clusters. The idea is you're only wanting to look at one image out of a cluster of images. And so how do you determine what image someone needs to look at? So we look at a number of different things. So we look at these boxes. We look at where they are, how big they are, the number of them, stuff like that, to determine then the best representative image for that cluster. And then also if we have a species classifier for your region, we're able to then also look at the species in those boxes, with the idea then that we can say, okay, if there are multiple species in one of the images, we can promote that as the best representative image of the cluster so that you don't miss out on the multiple species. And then if there's another species that's in the cluster that's not contained in the first image, the platform will force you to look at those other images to try and make sure you don't miss any of those multiple species cases. So we do stuff like that. And I mean, like the bounding box helps direct your eye as to where to look. So it helps, especially in dark images, stuff like that. We also do it in terms of cluster ordering. So we try and send you all the elephant images together, all the giraffe images together, stuff like that. Again, if we have a species classifier for you, obviously. And then that also just keeps things easier. It just makes the annotation faster and more efficient. Another point that's worth looking at is that the system is being a website. It's cloud-based and stuff like that. So that does have the drawback of having to upload your data set the first time. So especially if you're trying to upload like 300,000 images, that does obviously take a very long time. But the reason why we do this is because AI is unfortunately very computationally expensive, computationally intensive. So basically, on sort of an average work laptop that someone may have in the field, it would take weeks to process a couple 100,000 images, and that's just not feasible. So we rather have you upload these images to the cloud, and then once it's on the cloud, we can then sort of scale up our processing resources, process the data quickly and efficiently, and shut it down and try and process it as cheaply as possible as well. But it's also got some other secondary advantages. So for instance, your data is backed up and accessible from anywhere, which is also really nice to have. So in terms of individual identification, I briefly touched on that earlier. So in terms of AI, we've got an algorithm called Hotspotter. It's an open source algorithm, and it's sort of the industry standard. And basically it's pattern code recognition, so especially for stuff like leopards and zebra and stuff like that, where they've got very obvious and unique code patterns. It performs really well. On top of that, we also have a heuristic algorithm that you can also use by itself if Hotspot is not working well on your particular species. And basically the idea is they will look at a number of things. So firstly, we look at informational tags. So you can tag individuals as, for instance, completely, in a customizable set of labels, as male, female, adult, juvenile, has scar, missing ear, anything like that. And then also we sort of, as you build up an individual, you build up a territory map, a spatial map, as a function of time, so hence a space-time map. And essentially you can then say, okay, well, we're looking at an adult male with a scar, and we know sort of where it's been as a function of time. And we say, okay, well, other images of adult male leopards with a scar that have been found in similar time and space situations, and boost those suggestions and stuff like that. So we do things like that as well. In terms of outputs, you'll see this in the actual demo. But essentially, we've got a number of different outputs. We've got fully customizable CSV files that you can then, process with scripts and stuff like that really easily. We can also download your processed data, so you can have your labels in the image metadata. You can have the images sorted by species. You can also have all the image names contain all the information related to the image, including the species and stuff like that. And also we've got some built-in analysis tools, which you can see there in the screenshots that you can also play with. So basically, there are other systems that perform the same function as what TrapTagger does. They've all sort of come out in the last short while, sort of as technology has matured and is now capable of performing this task. And basically, so where we fit in that picture is that, and what our advantages are, is that first and foremost that we are completely open source and free to use. There's no intention to charge for the service at any stage. And secondly, the system, because it's been built to be more annotation efficient from the start, it makes it much easier to process your images, which in turn, again, the next point is that we can offer that speed accuracy trade-off, that you can go for a much more manual approach for much higher accuracy if you want to, and sort of do that on a per species basis, so that you just only doing it for your species of interest, so to optimize performance for your particular application. The next point is that we're completely data privacy focused. So coming from an African context, we understand that And obviously a lot of that there is a need for data security, so in particular like with Rhino images and stuff like that. Due to poaching, those images cannot be available online. If you've got anti-poaching cameras, you don't want those locations to become available online. So the point is, all your data is completely kept private to you, and you have control as to who can see that data. So the point is, that's one of our main focuses. Next point is that sort of our more focused AI approach. So we have much more regional classifiers, which then gives us much better performance on sort of rarer species in those regions. Also, thanks to our efficient annotation interface, we've got a very fast pipeline to basically process your data manually through the site and then use that training data to train a new classifier, and so that you can then have a classifier for your region. So we're able to provide that as a much faster process. And lastly, we also offer a full set of annotation features, all the way from species identification to individual ID in one system. And we also offer additional features like informational tagging, so you can add behavioral information and stuff like that to the clusters of images as well. So I'd just like to end off this introductory presentation with some acknowledgements. So firstly, I'd like to thank Paul Moritz, our founder and financier, for his continued support in the development of this platform. And then I'd also like to thank Bouvier Valley Conservancy, the Trans-Kalahari Predator Program, and Wild Crew for letting me use their data in this tutorial, as well as their continued support and collaboration.